Okay, let's get started. Can you hear me okay? Okay, first I'd like to introduce the talk and then myself and my co-presenter. So we'll be talking today about HTML5. As you saw from this morning's keynote, HTML5 is a big focus for us at Google for Google I/O this year. So I want to talk really specifically about some of the details, what we're doing specifically in Chrome around HTML5. So my name is Matt Papakipos. I head up on the engineering side the efforts to implement the HTML5 APIs inside the Chromium code base. And that's the code base out of which we build our Chrome browser, so it's very important to us. I'd like to also introduce Ian Fetty. Ian is the product manager for the HTML5 work inside Chrome and many other aspects of Chrome.
Thanks, Matt.
I should also mention we've got questions for this talk posted on Google Moderator, so you're welcome to submit questions there, and we'll go through some of those at the end. So I'll leave ample time for questions, both live and from Moderator at the end of the talk. So what got us here? What are we trying to do? So browsers started a revolution that continues to this day. We've all seen this accelerating trend for applications to move from desktop machines into the web. This all began with Netscape, right, way back. And initially, as you all recall, the web was initially quite static, right? You could go to a site, you could read some stuff. People started adding dynamic content initially by adding it on the server side, right? So you could do some sort of form fill out, do a post, get something back from the server that was somewhat dynamic, but there's always that server latency in the loop, and there were certain kinds of dynamic stuff that were just infeasible in that world. In '95, Netscape introduced JavaScript, which was quite revolutionary at the time, right? The notion that the web could run code on the client side was a radical concept. And I think if we think way back, we can remember some of those early applications of JavaScript. They look kind of comical now. There were JavaScript clocks. There were little things where, it would say, hello, type your name. You type your name, and it would say, hello, Matt. They look pretty lame today, but it's amazing to see what's grown out of that in the years to come. The other side of the problem that got some significant innovation in the late 90s was around network fetches. So initially there was XML HTTP and then XML HTTP request, which added the ability for web apps to do asynchronous requests to the server, get asynchronous data coming back, which was the other sort of missing piece of the puzzle. And again, we saw a bit of a lag between the introduction of the feature and the apps. In this case, it wasn't until a couple of years later with Gmail that we saw some of the first AJAX-style apps really take off, apps that were doing lots of JavaScript on the client, lots of asynchronous network requests. And then with the advent of Google Maps, we started adding graphics into this whole equation, using JPEGs dynamically, moving them around on the client side, scrolling them. And that's, at least for me, when this all started to get quite interesting, because I looked at the web and said, wow, it's starting to do graphics. It's starting to do real client-server applications. Now we find ourselves in a world where developers want even more radical capabilities. So things like playing video inside web applications seems like a mainstream idea today. It certainly wasn't 10 years ago. There's lots of other devices in your PC you'd also like to use for web applications. Microphone and camera might sound a little odd, but if you're doing a video conferencing application, that's a very natural thing to want to do from a web application. For many of these, we're starting to see browser plugins that allow you to do some of these things. For example, for Google Talk Video, we can do video conferencing in Gmail, but we have to provide a browser plugin, NPAPI plugin, to let you do that. It's cool, it does work, but it's not intrinsic to the web itself. So that's what we're here today to talk about. Other capabilities people want in their web apps is better ability to control file uploads, do multiple selections, do drag and drop, things of that nature. Geolocation is another big example. Phones started this, but we're seeing it move into laptops as well. My computer moves around a lot. I'd like to know where it is. I can offer you a better path to a local pizza restaurant if I know where you are. Offline capabilities. Google got started in this with Gears a couple years ago, and we're very interested in trying to figure out how can we make a web app work even when you're offline? How can we do syncing capabilities for web apps? Apps like Gmail let you use your email when you're on an airplane and you have no connectivity. And we're now seeing this move into mainstream HTML5, and I'll talk about that today. 3D graphics. So another area I'm very passionate about is 3D. I also run a project called O3D, and we're doing a tech talk later today. O3D is a 3D graphics API. Again, as with Gears, starting its life as a plugin, but we're expecting this to move into the mainstream browsers and into the standards over time. Audio, there's a lot left to do in audio. There hasn't been a lot of progress in this area, but there's many capabilities your machine has in terms of doing positional audio, multi-channel audio, and mixing that the web really doesn't take advantage of today that we think are going to be interesting for web apps over the next few years. So what's our goal, right? What's the endpoint that we want to get to? The endpoint I want to get to is if a native app can do it, a web app should be able to do it. There are definitely some challenges here around security, privacy, all the things that we know are important on the web today. But we can make the web much more compelling and interesting if we can bring these capabilities to the applications. The challenge is or the opportunity is to also do that in a way that is still conducive to taking advantage of the positive, very positive aspects of the web today. The fact that I don't have to install applications, the fact that they're always updated, the fact that they're integrated well with the cloud, they work well when they're online. All these are great things about the web we want to make sure not to lose in the process. So the process we've been going through at Google is to spend a lot of time talking to application developers. That's you, so we'd like to have a continuing dialogue with you about what you want to be able to do from your web apps. Figure out what native applications people run, and figure out how can we move those into the cloud? How can we move those into the web? That's the way we think about the problem. The next stage is implementation. So Gears is an example of that. O3D is an example of that. We're trying hard to innovate and create new APIs that do new things and get them out there in developers' hands as quickly as possible so you can try them out. With the full expectation that you'll want changes, you'll want new capabilities. We need to figure out how useful they are. And as we start to understand that, we work on integrating it inside our browser itself, and then work on standardization as the way to get it into other browsers as well. Right? None of this works if it's Chrome only. It's very important to us that this happens in all the major browsers, and the key to that is standardization. So Canvas is one of the great success stories with HTML5 so far. I think some of you saw this at the keynote, but Canvas basically gives you the ability to, from JavaScript code in your web app, do direct rendering to the screen. So you have pixel-level control. You can draw arcs and lines and text in a way that looks a lot like you would in a native application when you want to use graphics using an API like GDI or WPF or any number of different rendering libraries. So it's a 2D graphics, fully dynamic, callable from JavaScript. It's a surface on which you can draw 2D images, so you can identify part of your window that you want to do this rendering onto, and then make calls from JavaScript to do the rendering calls. There are a lot of interesting uses of this being demonstrated in the client developer sandbox out there. Some great examples are Bespin, for example, which is using Canvas for a lot of the rendering of the UI itself. I put a simple example up in the slide here to give a feel for what it looks like to use Canvas from JavaScript, and it's quite simple. You locate the Canvas object in your HTML code and do get context. You now have a JavaScript object that you can use to do 2D rendering. And now you just make a series of calls on that object in order to render into the rectangle on the screen. So fillRect will draw a 50 by 50 rectangle positioned at 0, 0 in the coordinate system. We can draw rectangles, we can draw arcs, we can draw text. So you have all the basic 2D rendering capabilities you need to do a bunch of interesting applications. So let's jump into a quick demo, Canvas. Ian, do you want to talk to us?
Sure. So this demo in particular and a number of demos using Canvas are actually available on Chrome Experiments, which you might have seen earlier. One of my favorites was actually done by a guy at Google named Dean, and it's called The Monster. And it starts off very simple. He's just drawing a square, but all of a sudden he's evolving this. He's using JavaScript to control this, to rotate this box, and all of a sudden it starts getting more complex. It starts splitting up into a bunch of polygons. It grows arms. And this thing just gets amazingly complex. But the cool part is it's all in JavaScript. This looks like something that I would find in a 3D screensaver. This is not a simple fill rectangle 50 by 50. This is incredibly complex. But if you look at the source, it's all just a bunch of rectangles. It's all just a bunch of JavaScript API calls. So here we're providing a very basic, fundamental API, and people are able to build on top of that and do incredibly complicated things, which I think is the most exciting part.
Thank you. Another area that we've been working on is local storage. So in general, this is to support offline applications. So applications that want to work when you're on the airplane, when you're in airplane mode, when you're in an area with bad reception, you don't have Wi-Fi available. So it's a way to store data client-side. So it gives you access to the local disk so that you can store your offline email, you can store images that you want to work with, whatever the web app wants to do. And the cool thing is, since this is an API, it's really up to your application to figure out how you want to use offline capabilities, right? So you should look at it from the point of view of, well, what is my application? Is it a photo editing application? Is it an email application? Is it a social application? And figure out what are the aspects of that make sense to do while you're offline. And certainly for Gmail, if you're offline, writing email while offline, reading email are perfectly sensible things to do. And Local Store provides the mechanism for doing that. So there's two APIs, the database API, which is basically a SQLite interface. It gives you an SQL interface to do inserts and deletes and lookups inside a SQL database stored on the local computer. The other one is the structured storage API. This is what's called Local Store, which is a somewhat simpler, easier to use API that gives you effectively a persistent hash table. So from your JavaScript code, you can store things, key value pairs, from your web app. When you do that, if you then fetch them later from your same web app, whether you're online or offline, you get the same values back. So basically a persistent hash table that you can use to store data on the local machine and get it reliably whether you're connected to the network or not. This is something we pioneered with Gears originally a couple years ago. And the cool part is we've been successful over the last year of getting it standardized by the W3C. So it's now part of the web standards themselves. And so we're hard at work right now integrating this into Chromium and Chrome. And some of the other browsers, in fact, ship this already. For example, Safari browser currently supports the database API fully. So to give you a feel for what it looks like, I put a code sample up here. So here we're fundamentally just executing an SQL statement. So if you're familiar with SQL, this is the language or the syntax you use to do modifications of the database, whether it's a lookup or a store or whatever. So in this case, we're doing execute SQL. We're doing a select. And a select in SQL lingo is just a lookup. So if you look up SQL syntax, that's how you look something up in the database. So it's saying fetch all fields from my table. And SQL is quite a flexible format. You can do searches with it and find things that match. It's quite a sophisticated way to manage the local database. The good news is if you're familiar with doing server-side web applications, you're already using a database of some kind, and in fact, you're probably using SQL. So it's actually quite easy to learn this if you're familiar with server-side web app development. The best demo here of local store is, that I can think of is probably Gmail offline. It's worth giving that a try if you want to get a feel for sort of what it feels like to use an offline capable app. And the interesting demo is just turn it on, wait for it to sync your email, then turn off all your network connections, open your Gmail, and it's still there and it still works. Another interesting aspect of the offline application problem is syncing. I just mentioned it. We all know that you've got to be really careful when you write web applications not to lock up the browser, right? If I write a while one loop in JavaScript, the whole thing locks up, it stops refreshing the screen, bad things happen, users are unhappy. This is quite a challenge when you're doing offline applications, because if I turn on offline in Gmail, I may need to sync 200 megabytes of email if I've never synced before. I don't want to just do that inside a loop in my main JavaScript thread, or I'm going to lock up the browser. So workers are a nice solution to this problem. They give you the capability to run a background thread effectively. So if you look at desktop operating systems, they have threads and they have processes, right? They have ways that you can, in your application, express concurrency through additional threads of control. Fundamentally, that's what workers are. They give you the ability to start up a background thread called a worker, and it runs in parallel with your main display thread, which means you can, in the background thread, you can do as much I/O as you want, and you don't have to worry about locking up the browser display. So workers are quite rich. There's 3 different flavors of workers that are in process and are at various points of specification and standardization. The most mature of them right now are dedicated and shared workers. So dedicated workers are effectively bound to a single tab. So what this means is if I have a browser with multiple tabs open or multiple windows open, if I start a worker up in that tab, that worker is specific to that one tab. So if I have multiple gmail.com tabs open, this worker is specific to this tab, and the other one can start a separate tab. There's a different flavor of these called shared workers. And what this means is I have one background worker thread that I want to share between all the tabs at my domain. So if I have multiple tabs open at gmail.com, shared worker, if you start that one worker up, it's shared by all of the tabs at that domain. So a good example of why you would want to use a shared worker is something like syncing your email, right? If I have multiple tabs open at the same email address in the same account, I'd just as soon have them share the syncing rather than sync separately, which would make no sense. The last category of them, and this is the newest one, it's not quite finished with standardization yet, is what we call persistent workers. The idea here is there are some things you'd like to do in web applications where you'd like background execution ability, but you want to run it even when the browser isn't running. And a great example here is Gmail itself, right? I would love to have my Gmail sync even if the browser's not running, even if Gmail's not up in a tab right now. I'd like to make sure it's synced all the time. Another good example is notifications. There's certain applications like email where you'd love to be notified when you get email, even if you're not running email right now. So persistent workers are still in a somewhat experimental stage, but there's an ongoing implementation effort in the Chromium and WebKit codebase to try to bring this out. And the development of this is ongoing in WebKit and Google Chrome. So some versions of this work in Safari now. It works in Gears now. Dedicated and shared workers work in Gears. And we're working in Chromium and WebKit on persistent worker implementation as well. Okay, application cache. So the last piece of the puzzle for offline capable applications is app cache. The problem that app cache solves is, picture yourself going in the airplane. You've got no internet connectivity. You type in gmail.com. Well, you're going to get a server not found error because you're not on the network. So app cache solves this problem. App cache provides a mechanism where your application can create a manifest file where you specify these are the URLs that I want to have access to when I'm offline. So you literally specify a list of these are all the URLs at gmail.com or whatever your domain is where these are the URLs I want to access when I'm offline. App cache then syncs those for you so you have a local copy on the machine. And thereafter, once you've enabled this, if it finds itself not in the network and you try to fetch a specific URL, it'll fetch the version off the local disk. So this can include your HTML content, it can include your JavaScript content, and it can include JPEGs. So you can basically sort of freeze dry your application on your local machine and then fetch it as if you were on the network. Again, the key to how this works is this manifest file. And what that means is that you have full control over which parts of your application are accessible while offline. There may be parts of your application that don't make sense to do while you're offline. For example, searching a big database backend may not be feasible when you're offline. So you can decide that parts of your application are cached and parts of it are not cached, both statically in the manifest file, or you can dynamically add things to that list of cached entities. So this is implemented in WebKit today. It works in Safari today. We have it working in Gears, and then implementation in Chromium is ongoing. So we're most of the way through implementation of this in Chrome itself. Video. So moving out of the offline arena into some of the newer areas, video is one that we're very excited about. So we recently launched this in Chrome, in the dev channel of Chrome. So the sort of experimental builds of Chrome now have video tag support. The problem this is solving is sort of how do I play video on my website and do it in a way that's intrinsic to the web, right? So what's neat about the video tag is without using any plugins at all, I can create a web page where I just create a simple video tag. So I said video source equals video.mp4, position it where I want it, and then there's video playing at that part of my web page. So putting video in your web page becomes as simple as putting an image in your web page, right? Today, to put an image in, you put an image tag, you say where you want the JPEG, you're done. Video now becomes that simple. There are built-in playback controls, so it comes with a stop and a pause and a play button. And there are controls that you can use from HTML or from your dynamic JavaScript to turn the controls on or off, depending on whether you want to use an alternate control representation, you want built-in controls. It's fully under your control as the web developer. There's also full script control over the video itself. So if you want to control when the video starts or what happens when it finishes, you can set up callbacks, you can trigger play, you can change video streams. There's quite a flexible JavaScript API. So for Chrome, what we've done is we support the MP4 container with H.264 video decoder and an AAC audio decoder. So some nice commonly supported formats work built in the Chrome dev channel and will be making their way out through to all the Chrome users very soon. There's also a set of formats that Apple currently supports. So Safari has got great support for video, and we're excited to see this moving into a bunch of browsers. The other codec set that Chrome supports is an OGG package with Theora and Vorbis decoders. So we've got both a traditional H.264, the same format that we use on YouTube, available today, and then there's also a full open source code stack for an IP-free stack for doing it as well for Theora and Vorbis. Okay, so let's do a demo really quick of video. It's fun to give video demos because they are just cool.
Great. So as Matt said, video is actually extremely simple to use. One of the, I like to say it's as simple as putting an image on a tag, on a page. So I want to actually demo that. What I have right here is a video on a page. It's simple. It's a simple video. It's a simple page. And you can see that the video is playing. If I hover over it, I see I've got...
Just going to kill the audio.
Thank you. If I hover over it, I've got the default controls. I didn't have to build these. They came for free. I've got pause over here. I've got a little slider. And I can mess with the volume settings if I want. And to show you how simple this is, I want to show you the source code for this page. I can make this a little bigger.
As it should be. It's tiny.
Yes. It's very tiny. All I have to do is just put in a video tag, point to my video, and I just put in two optional attributes here. Controls gives me those default controls that you saw, and autoplay makes the video play as soon as it's loaded. Dead simple. There's some alternate text here in case your video doesn't, in case your browser doesn't support video, and that's it. If you want, you can make this more complicated. You can script it. You can change the playback speed. There's all sorts of things you can do, but if you want to be dead simple, you can.
Cool. Thank you. Another big area we've been working on is rich text editing. So as many of you have tried this, I'm sure, and spent a lot of time working on rich text. Rich text today on the web is quite hard. What I mean by rich text editing is having a text entry field where the user can look at text, which is rich in the sense of having bold and italics and fonts and different point sizes, right? All the things that we're accustomed to expecting out of modern document systems. Well, the only thing really built into the web here today is text boxes, which are very lean and mean, right? No control over fonts or bold or italic or any of that. The web for a long time has had this capability called content editable, where you can specify at a tag level that a certain subtree of of HTML is to be editable in the browser window. The problem with this is the implementations have been wildly inconsistent, as many of you know. So how certain tags behave when they're in a content editable region changes dramatically between browsers. Whether they support selections and copy and paste varies dramatically. What this means for us at Google is that in Google, when we do an application like Google Documents, where we let you edit text in a rich text format, we're using content editable, but we also have to download 200 kilobytes of JavaScript code to handle all the browser differences that are entailed from these implementation differences and how content editable is implemented in different browsers. So 200 kilobytes of code may not sound like a lot, but that's a big deal, right? It's a big deal if you're running this thing on a phone, or you're running in a bad network connection, or in a part of the world that has very slow internet connectivity. And even for the rest of us, with right here with a good network connection, it adds latency, right? This is adding latency to page loads. It's kind of crazy that when I go to Google Docs and open a document, I have to spend time downloading 200 kilobytes of JavaScript code just to deal with browser differences in rich text editing. So we're very excited about this area, and we're doing quite a bit of work in it right now. A lot of the work right now is in specification. The weakness of content editable has always been that the spec has been weak, and this is why the implementations are also different. So we're working quite a bit right now to spec out with the W3C a better spec for exactly how should content editable work. How do we spec it in a way where we have built-in support for cut and paste, for good support for selections, for a consistent set of fonts and bold and italics and all the things that we make sense, that we expect in there. I mentioned exec command in here. This is the ability to, once the user's made a selection, make it bold, make it italic. This is an example of one of the areas that's very inconsistent between browsers right now. And one of the reasons we have to download so much JavaScript code to work around these issues. So the endpoint we're working to get towards is to make it so that rich text editing is also a one-liner, right? It becomes as simple as text box has always been, right? I just say, give me a rich text area, make it all fully editable, and then I can expect a consistent set of HTML that will come out in response to user actions. So we want to make it easy for the apps. So that's still in the early days, but expect more from us over time. Notifications are another big area we've been working on. Currently, for a web application, you have a limited set of ways that you can get the attention of your users. You can do something in the tab, right? But then you have the problem of what if they're not in the tab right now? So the other alternative is alert boxes. The problem is users hate alert boxes, right? I come into work every day and find an alert box open saying that I have a calendar entry coming up, and my whole browser is locked up till I address that alert box. It's not a great user experience. Alert boxes are not very flexible, and I don't get alert boxes if I'm not running the browser as well. So we've been working quite hard on trying to figure out what is a less intrusive event notification mechanism, and one that has better control over presentation, and one that is more reliable. By control over presentation, I mean, how do I do rich text in it, right? The current alert boxes, it's really just an ASCII string. I'd like a little bit more control. I'd like it to look like the web and feel interesting. And I want it to work regardless of which tab or window has focus, or whether it's iconified, or any number of different factors. So we're currently prototyping some implementations of this. Again, this one is in the very early stages. There's no standard here yet, and we're in the prototyping stage, and would love input about what people want. But what we're trying to achieve is to create a notification system where your web application can just register, say, I want to present notifications, make API calls when you want to present a notification, know that the user will get it reliably, have a way to get back to your application, and it won't lock up the browser in the way that the alert dialog box does today. WebSockets. So as you notice, we started with sort of the stuff that's furthest along in implementation, the things that we're shipping already. Now we're moving into the realm of things that we're just beginning work on, but areas we think are very important and things that we'll be launching over the next few months. So WebSockets. This is a very interesting area. So if you look at how network communication works for web applications today, it's frankly really weird, right? It manages to work, but when you look at how traditional desktop applications do client-server and client-client communication, it's a very different model, right? You open a TCP connection to a server, you have a persistent connection open, you can send packets both directions, receive packets, it's all asynchronous, it's all very simple. The web has a very different model, as you know. You do these asynchronous requests. When you want a persistent connection to the server today, it's actually quite complicated. There are two challenges. One is, how does the server notify me asynchronously? because there is no persistent connection. The other one is, how do I have a consistent connection that I can do bidirectional sends and receives on? So today what people do is things like hanging post requests as a mechanism to allow you to get asynchronous notifications. It's a weird way, and it's somewhat unreliable, and there are many challenges that I'm sure you're familiar with hanging post requests. WebSockets are an API that are already specified in the HTML5 spec that try to solve this problem. So it's an API that looks a lot more like a normal TCP connection. So it's a way to create a connection back to your server from the client, and then simply do sends and receives and asynchronous callbacks when you get receives. So a very sort of TCP-like protocol for web applications. So it means it becomes easy to get asynchronous notifications. You already have a socket open. You just get an asynchronous send. You do a receive. You get a callback. It becomes much simpler to implement asynchronous notifies. It becomes much simpler to do the sort of persistent connection with bidirectional communication. So there's a specification already here for HTML5. There's some work still ongoing to refine defining the protocol for how connections work with the server and several other aspects. And we're beginning prototype implementation so that we can start to use this, start to experiment it, and get it in the hands of folks like yourselves. But the goal here with WebSockets is to make persistent server communication, asynchronous notification to the server, much simpler. 3D graphics. So this is an area I'm personally very excited about. So there are two big efforts that have been going on in this area that we've been contributing to with Chrome. One of them is Canvas 3D. So Canvas 3D is a system developed by Mozilla, an immediate mode API that allows developers to make OpenGL calls from JavaScript. So OpenGL is one of the dominant 3D graphics APIs that we'd use from Windows or on the Mac or on Linux. It's the industry standard for 3D graphics for native applications. So Canvas 3D is effectively a set of JavaScript bindings that let you call OpenGL from your JavaScript application. So this is running as an extension in Mozilla today, and is very cool stuff. And we're actively collaborating with them on figuring out how to bring this into Chrome. It's something we're very excited about. O3D is another effort in this area. This is a plugin that Google launched just over a month ago, and it's a set of APIs for doing 3D graphics from JavaScript. This one is different from Canvas 3D in that it's a retained mode API. So I guess the way to think about the difference between Canvas 3D and O3D is Canvas 3D is immediate mode, and O3D is retained mode. So there's a good analogy there between Canvas 2D and SVG, right? SVG is a retained mode API, whereas Canvas 2D is an immediate mode API. And so what we're seeing in 3D is that there's a similar dichotomy. There are different kinds of APIs, depending on whether you want immediate mode to make rendering calls that render right now, or whether you want to make retained mode rendering calls where you define a scene graph, which is then rendered by the system automatically, in the same way that SVG is, or the DOM is, right? In a sense, the DOM is a retained mode API. I create the DOM, and then the browser takes care of the rendering for me. So our expectation here is that this is going to continue to evolve. We're in the very early stages right now of working on standardization. There's a couple different prototype implementations out there right now, and we expect it will take several months to really get to final set of specifications. Could easily take years. So we're actively working with Apple and Opera and Mozilla to move this forward, and it's in the very early stage. If you're interested in this, I'd encourage you to go to the client demo pod outside. There's some pretty neat games that folks have written with this stuff, games and other applications from ABC and Disney and some game developers we've been talking to. And there's a lot more. So I'll say a lot on this slide about some of the other things that we're thinking about, that we're beginning work on. These are the things that are the furthest away. Many of these are ones we haven't started on really at all yet, but we've realized that they're important areas, and they're areas where we, the open source browser community, need to make progress. And we'd love to hear from you about what the additional things are that aren't on our list. What else do you need? But let me go briefly through the ones that we know are important. So there are some that are already defined in the HTML5 specs that just haven't been implemented that we think are important. Geolocation is a good example there. So there are good specifications for how to make JavaScript API calls from the client to figure out where you are in the real world, right? What are my geolocation coordinates? Those work by using backends that are either cell tower based or Wi-Fi network based, or based on GPS hardware in your device if you have it. What's neat about the API is you don't have to know how it works. You just make a simple API call and say, where am I? And it gives you latitude and longitude coordinates. Very simple. Forms 2. So Forms 2 attempts to improve how forms work on the web. It's again, one that is specified. There hasn't been much work on it. The main things that are interesting about the Forms 2 specification, if you want to check it out, is it's got consistent HTML interfaces for things like calendars, right? We've all seen web applications where you click on a date field and it pops up a calendar. Well, that's always a custom piece of code. There is no built-in thing in the web that says, let me pick a date now, which is why all those calendars look different. What Forms 2 tries to do is say, let's standardize all that stuff. Let's make it so that doing a form that needs a date entry is just a one-liner where I say, it's a date, I use the date tag, and it gives me a calendar. I select the date, and it fills it in the form. And so Forms 2 aspires to do this for as many different data types as possible, make it easy to enter them in a visually interesting, sensible way with less code from the app developer. Data grid is another API that's been spec'd out that hasn't been implemented yet that we think is pretty interesting. So data grid attempts to give you better control over table-like layouts. So let me get into some of the more exotic things. So in the last category are things that are really not very well defined right now. We think they're broad areas that are important and interesting to add as capabilities for web apps, and we'd love to get your comments and questions during the Q&A at the end about these. So some of the ones we've been thinking about are peer-to-peer APIs. Right? There are a lot of applications I'd like to do, like chat applications or games, any number of different things, customer support, where I really, it doesn't necessarily make sense to do client-server-based communication. I'd just as soon do peer-to-peer communication. Why? Well, one issue is latency, right? If I can do peer-to-peer, it's one hop. If I have to go client to server to client, it's 2 hops. If I'm playing a game with the guy sitting at the desk next to me, that really makes no sense, right? It should just be 1 hop to the guy who's 2 milliseconds away on the network. So if we look at conventional desktop operating systems, there are great peer-to-peer networking APIs. The challenge for us is to figure out how do we bring that to the web? How can we create a peer-to-peer networking API for the web that's safe and secure, that gives you these capabilities? So it's something we're starting to think about. Drag and drop support. This is another thing that doesn't work very well on the web today and is going to require some work from the browsers. I'd really like to be able to drag files from my desktop into my web application and have that work reliably. And I'd like to be able to drag it between web applications, right? If I'm looking at an attachment that I just downloaded in Gmail, or I haven't downloaded, I see it in my Gmail, I'd love to be able to just drag that to another web application. Why can't I do that today? Well, because we don't have the APIs. There's no rocket science here. We just need to figure out how should the API work, how should the security model work, how does user grant permission for this? The wonderful thing about drag and drop is, in a sense, the user is already granting permission by doing the dragging. So it does seem like a solvable problem, and it's something that we're starting to look at pretty seriously, and would love to hear from you about. Webcam and microphone, as I mentioned the Google Talk video conferencing example. There are lots of apps people use today for doing video conferencing on the web. None of them are really web apps, right? So they may have a web interface of some sort or a control panel, but doing the heavy lifting of accessing the webcam, accessing the microphone, running the compressors is always stuff that people have to do either in native applications or in plugins. What we're trying to figure out is how do we get to a world where I could write an application like that purely in JavaScript? And it doesn't look that hard. You really just need to add JavaScript APIs for getting access to the webcam, access to the microphone, support for a reasonable array of codecs for live encoding of video. So it's an area we're starting to look at quite seriously. OS integration. So this again gets back sort of to the drag and drop thing, but there's a broad category of things that native apps can do that web apps can't do that are hard to put in any other bucket. So I put them in this bucket. These are things like, there are files I may have on my desktop, like a doc file, where I could double-click on the application, and I can get that to launch Office today, but what if I want it to launch into Google Docs? What if I want it to launch into an online PDF previewer? So beginning to think about how could we do that? How could we have local file handlers that respond to OS events like opening a file that are capable of launching web applications, right? There are an increasing number of web applications that can handle things like doc files or Excel spreadsheets or any number of different formats. Photos, right? Photo editing, for example. So we're starting to think about that level of OS integration. Another one I think about a lot is CD-ROM drive or USB key. There are various devices that are hard to get to right now from the web. It would be nice to be able to pop in a CD that has photos on it and have it bring me to Picasa. We're not there yet. So we're beginning work on this, starting to think about it, and would love to hear your thoughts. Another broad area, one of the last I'll talk about is uploads. Uploads on the web today are not a good experience for users, right? If I decide to go upload a bunch of photos to a website, if it's a pure web app, that's a pretty awful experience. I have to go to the website. I say I want to upload a photo. It brings me a file open dialog box. I have to go find the thing on my file system by traversing around the directory hierarchy, clicking. I find it. It closes. And now I say, oh, now I got another 50 to add. So now I do it again 50 times. It's a really horrible experience. So we're working to think through how should this work? How should the user select multiple files? How do we handle the upload? How can we handle restartable uploads? A big issue is a user will begin an upload, close their machine, walk away, goes to sleep. I've just destroyed the upload. How do we make this a better experience? That's something we're beginning to think about, and we think it's a very important area for users. Lots of evidence from that in that there are many third-party Windows applications that are sort of uploader applications, whether for Flickr or for Facebook or whatever. We're trying to figure out how could we move those into the web itself. These are some of the areas we've been thinking about in terms of things that the web needs in terms of client-side capabilities. But again, we'd love to hear from you about what's important, what's not important, and what's missing from our list. So quick summary, my last slide, and then we'll open it up to questions. So here's a rough timeline of what we're working on. So we've been hard at work on video and launching that into the dev channel. That's sort of where we are right now. We're hard at work on local store, app cache, workers, database. A bunch of those offline capabilities are already shipping in Gears and have been for some time. We're working on shipping them in Chrome as fast as we can and checking them into the Chromium code base. So if you look at the source tree, you can see the check-ins happening now, and those will be coming out as soon as we're done. The next-gen stuff we're working on, I mentioned a couple of them today, are WebSockets. Another one I didn't mention is CSS3. So we're doing a lot of work with CSS3 to support some of the advanced features like vertical text rendering for Asian languages, support for things like Ruby and other things that are used in a lot of languages with multiple character sets to show different representations for the same text. Working on that. And then longer term, working on some of these more exotic things that I mentioned. So 3D certainly being one of them, but also things like peer-to-peer, better support for clicking a doc file, having it open a web app. So this is our roadmap. These are the things we're thinking about. We'd love to hear from you. So I will open it up to questions. And we also have a Google moderator forum we'll pull up to answer questions on the web. So why don't I take a live question first? We've got a microphone there and a microphone there. So please walk up to the mic. And we'd love comments or questions.
We've got 17 questions on the moderator.
One thing I was wondering if it's being thought about for the future of browser support is window management. Because we build and maintain a web application that we wrap in Chrome, and it's designed to be used on multiple computers with multiple monitors. So we're dealing with multiple windows, multiple tabs, and even inside those, some of them are frame sets, some of them have iframes and stuff. And frankly, it's very difficult to find a window from another window, depending on some are popped up because they were called by window.open, some were created by somebody browsed to the same domain on a URL, that kind of thing. It's just very hard to get to be able to hit a button in one window, find out where that other window lives to actually call that action and do some work. I don't know, has there been any discussion or progress or thoughts on that?
It's not something I've thought about personally. I think it's a great question. You're right. If we look at how desktop applications behave, they'll often bring up a set of windows, right? I'm thinking of like a video editing application or a 3D graphics modeler, right? It'll bring up the main editing window, some extra views, a list view, a file view. You're right. Why can't we do that from web applications? That's a great comment. We'll think about it. Cool idea. Yes, in red?
How is HTML5 going to be able to handle when a user does not have a codec installed for video?
That's a good question. So how do we handle a missing codec? So we've defined the set of codecs that we do support in the implementation right now. Today, it's a fixed set of codecs, so there isn't any way to sort of plug in another one. I mean, of course, you could check in code into the code base and do it. It's all open source. Yeah, I don't have any specific thoughts there. Ian?
So, I mean, we're definitely trying to talk to other browser vendors, to other people that are involved in the space, so video editing software. And ideally, we'd like to come to a place where there is a set of things that if you do, it just works. Like right now, I know that if I make a JPEG, a GIF, or a PNG without transparency, it'll just work in pretty much all the browsers. We're trying to get to a point where there's something similar for video. So we're supporting H.264 and OGG. There's not 100% agreement yet. We're working to try to get some consensus and some sort of, I don't think this is going to be something that's part of the standard, but we're trying to get some sort of industry best practice and consensus around if you make a video like this, it will just work. So that's something that's really on us, but also on everyone else to sort of, help participate in that discussion, help reach out to other people involved in the video space, and help this discussion move forward towards a consensus.
Hi, my question is the file name you put in the video tag is limited to the local file or can refer to the remote file?
It's just like an image. It can be, this one happened to be a local file on my computer, but I could say http someothersite.com/video.mp4, and assuming that they didn't have some htaccess rule restricting it, it would work.
You can also do HTTPS. I don't know if FTP works, if you're brave.
So streaming is something that we still have to look at. Right now, we don't support any streaming protocols, but it's something that we're looking at. We should also be sure to take
let's
some of the
take a couple
questions
from moderator, to be fair to the web folks here. First one?
That was just a vote.
Okay. Do you believe it's safe enough for us to start developing sites or web apps leveraging HTML5? It's a good question. I think the ones that are implemented in multiple browsers are certainly things I would be comfortable using in a web app that I shipped. I mean, you've got to figure out what makes sense for you. The way that the security policies around these APIs work tends to be fairly browser specific, right? In many cases, for things that are privacy related or things that may consume local resources like disk space, browsers tend to go with interfaces where they bring up a dialog box to check with the user on first use, to ask the user explicitly to grant permission, should this thing be able to work offline? Should this thing be able to pop up notifications? In general, the browser vendors have done a very good, thoughtful job at making sure that they seek user permission when important for this stuff. So I think in general, there has been a lot of thoughtful work about security and privacy for these APIs. Certainly, some of them are in the more experimental stage still. I'll be the first to say that. Like 3D graphics, for example, is still in the early stage, somewhat experimental at this point. It's not built into the browser itself. But the ones that are built into the browser, I can only speak for myself. I would be comfortable deploying a web app that used them.
And we should point out that if you go out to the developer sandbox, there's a number of people that are using that. So Mozilla has the bspin project, which is using Canvas. And there's always some chicken and egg scenario, but certainly a lot of these do already have good implementation across multiple browsers. And I think that if you are doing something that is so new, so innovative, and just looks so cool, I think if you say, you need to upgrade your browser and you need to get something new, it's not going to work for 100% of people, but that's how we move forward.
Cool. Okay, let's take a live question.
So I got a quick question for you. regarding this canvas, I mean, there is no events on individual graphic elements that are on your canvas. Is there any plans at any point in time to be able to support that? Because SVG has it, VML has it, and I mean, that is just imperative for us to be able to have that. Is any plans at all?
That's a great question. And that actually gets back to one of the issues I was discussing about sort of the differences between immediate mode APIs and retain mode APIs. The challenge with immediate mode APIs is that things like picking, which is what you're describing, right? How do I click something and get a callback? Make more sense in the context of a retain mode API like SVG than they do in an immediate mode API like Canvas. So I think my prediction is Canvas probably won't grow that ability, but some of the retain mode versions of it are probably easier ways to do that. I guess I'm thinking about that specifically in the 3D realm. I haven't heard specifically about any sort of picking support for Canvas in the works so far. I think you might find SVG is better for that sort of thing, though.
Right. And you guys, I mean, all your presentations, even this morning with Vic, I mean, you always seem to exclude IE out of this whole equation. But I mean, unfortunately, IE6 is still around and it's really killing us. And is there any effort on your side to kind of bring them onto the table and try and say, hey, you know what, you guys have to start adopting the HTML5 stuff?
It's a good question, yeah.
I think we should give some props to Microsoft. Like, they have started implementing some of the HTML5 features in IE8. Obviously, we'd love to see them do more. It's an open standard, and you know, there are Microsoft people in attendance. They have name badges that say Microsoft. You should corner one of them and share your opinion.
It's like they come to conferences and say, hey, you know what? We got CSS 2.1 completely implemented now. You're like, come on. I mean, people are at 3.0.
Yeah,
Thanks.
I think we can't implement it for them, but I have seen a lot of signs that they're taking.
You guys at Google, you should be able to implement it for them. Come on.
Thanks. Let's take another moderator question. So, question is Chrome for Mac. That's a short question. Let's see. Well, it's open source. Go build it and run it.
It runs Gmail now.
Right. I mean, that's what I do.
It's getting better.
So, but nothing specific to announce about public plans for an official build, but definitely there's lots of code in a very workable, usable state, and we want to make sure it's really polished before we do anything final that would affect end users. Cool. Okay, another live question.
This is actually about the worker threads, and I was curious if there's any sort of like mutual exclusion to avoid like race conditions.
So, JavaScript in general tries to avoid the notion of locking anything that would require you to do locking.
Oops, I lost a mic.
But what I was thinking about is like for file access, when you have offline programs and all that, and you start doing stuff that is like on the file system or just not necessarily a variable. Is there any sort of thought on that maybe?
I mean, the general style, the way it works, tends to avoid that kind of stuff. I think you probably could get yourself in a deadlock if you tried, but it tends to be somewhat immune to that because of the way the API works. There's two factors that make that the case. One is that all of the receive calls are basically callback-based. So you tend to receive a callback and do something. In a lot of deadlock cases I've seen, in conventional operating systems, you get into deadlock situations because you've got reads going on both sides of a pipe. So this is a more callback-oriented thing, so it's somewhat immune to that. I think you probably could make it deadlock if you really try, right? If you push a bunch of messages to someone and the other side's not listening, eventually it will back up.
I would say that if you come into one of these scenarios where you think that you need locking or you think that there might be deadlock, these are definitely new APIs. The best thing to do is to get on the WhatWG mailing list. They're open. Anyone can email to them. And just send an email saying, like, look, I think this is a scenario where locking would be really useful, or I might need locking, and then start a discussion around that, because these still are at the early stages, and discussion is most welcome.
And it's entirely possible we need to add something we haven't figured out yet, so let us know if you need it. Cool. Let's take one more moderator question. Is there any work for client-side web applications to gain access to server-side persistence model using a standards-based protocol? That's a good question. Well, let's see. Not that I'm aware of. Most of our thinking about offline so far has been on the client side in terms of how do we have the fundamental storage capabilities, how do we do app cache, how do we have a way to capture URLs and display something off the local file system. So I think for the most part, we've been thinking primarily about the client side thus far. There certainly are Google technologies like App Engine you could use to store things on the server side, and you could build a persistent storage mechanism that way. But I think it's largely up to the folks in this room, right? You guys are the developers. We sort of are providing the low-level client mechanisms and the server-side services like App Engine. You should be able to, I think, build the kind of persistent system you're looking for on top of that. Yes, live question.
Okay, you talked about APIs to device functionality, location, and the camera microphone. And I wonder, WTC is currently starting up an activity intended to define a bunch of device APIs for web applications, and also security model. Which is Google's view on that? Will you support that activity and be active in that group?
So I don't know if we actually need a full W3C activity for this. I think a lot of these are more straightforward, and we'll just have to see as time goes on sort of what gains traction and what doesn't. I don't know at this point in time that we would say we support a W3C activity.
So you don't believe it's a good idea to standardize device APIs, or?
I think that as time goes on, we'll try to figure out what APIs make sense to standardize. I'm not making any statements about whether a W3C activity is necessary for that or not. I think that, certainly we've got a lot of browser vendors involved. We've got a lot of interested developers involved, and that as time goes on, we'll see what direction this goes in.
In general, the approach we've found works best with standardization, and I guess I found in my career even before Google, works best is to prototype something first and then try to standardize it. So for many of these things we're talking about today, like peer-to-peer and stuff like that, honestly, I don't know what I would propose to the standards organization today, right? The first step for me is to start sketching out some APIs, prototyping some things, seeing what actually works, getting some people to try it. So for many of these, we're not quite at the point of standardization yet. So far, the model that the standard orgs have been doing is to do individual standards for these individual APIs. You're describing a somewhat more overarching thing. There hasn't been any movement in that direction thus far. It's been more individual standards for specific proposed APIs.
So let's take another question.
Okay,
thanks.
Hi. So with HTML5 and going forward, basically we'll be using more and more of desktop capabilities. So wouldn't the browser actually turn into a cross-platform runtime which is capable of running applications in a way? So are we actually moving towards an application model only, or how is it actually different? Apart from, I do not need to probably install and uninstall an application. What other differences would I get?
That is very much how I think about it, right? We are, in a sense, making this application runtime. That's what a browser is, right? A browser is, in effect, to the applications running on it, a browser is almost like your operating system, right? You think when you're developing a web application and debugging it, you're thinking more about the browser you're in than the OS you're on. So I think we very much think about it the way you describe. I think that's a fair thought. It is the browser is the runtime for applications.
Okay, so the only difference would be that the applications would be cross-platform, right?
Yeah, and I think that's one of the neat things that browsers bring to the table is that if I know I run in Safari, then I run in Safari on Windows and Mac. And if I run in Firefox, I know I run on a variety of operating systems, Linux and Windows and Mac and others, right? So I agree. That's one of the really cool things about the web, and it's one of the properties we want to preserve as we add these new capabilities. Great question. Cool. Should we do one more, moderator?
I think we have time for one more. So there's a question on, there are many HTML5 features that support accessibility, e.g. deep linking into applications for screen readers. Can you detail what work Google is doing to extend the web in those directions? So I think a lot of the work that we're doing is trying to make as much possible in HTML and open standards as possible. So one great example for that is the video tag. We're trying to work on support for closed captioning in video in multiple formats. We're looking at what do you need to do subtitles. We're looking at simple subtitles like subrip and more complicated things like ASS, so that it is possible to do to make better accessibility for these new APIs.
Cool. Okay, time for one more live question. Go ahead.
We can see that HTML5 is really powerful. Everybody is happy with it. But based on it, the browser must be very complicated. It becomes a monster. It has a DBMS to support a CQ. It has codecs to support videos. Then it will become bigger and bigger. How can we get these browsers into mobile devices?
Okay, so yeah, the question is how do we get these to mobile devices? Well, the good news is they're on mobile devices, right? Many of the HTML5 APIs I talked about today work on mobile browsers. And again, as with desktops, it varies depending on which browser you're on and which phone device that you're on. But a lot of the capabilities I talked about, like app cache and database and geolocation, work on the Android browser today.
And the iPhone browser.
And the iPhone browser, yeah. We should give a lot of props to iPhone. iPhone has been very early in a lot of these HTML5 features for the browser for iPhone. So we're seeing some very encouraging work going on in that area. I mean, the good news is the memory and flash capacity and whatnot on the phones are going up, so they do seem to be adding these things. There may be some APIs that phones don't add as quickly as desktop. I think a good example there is 3D, right? 3D graphics is just starting to take hold, I think, for laptops doing web browsing. Not quite ready for that on the phone. It will come, but I think we're a little bit early on that still. So we will, in some cases, see the phone come a little bit later, but the gap there is getting shorter every year. It seems like phones are starting to take up some of these features faster than I would have predicted a couple years ago, which is great to see.
And as we can see in the demo, we only support like 2-3 codecs for video. And I believe in the future, and we all want to support almost all kind of codecs. And for the CQ, we want to be as good as the DBMS. We have transactions, we have log,
I'm going to jump in there really quick with regard to video codecs. I don't know if we actually want to make it that complicated. One of the nice things that we have right now is it's something new, and we can define how do we make it simple and work. Like if you're a browser vendor, you have to worry about 50 different image formats right now. You have to worry about GIF, GIF98A, JPEG, JPEG 2000, TGA, tons of codecs. And it's just complicated. So I think what we want to do is we want to make it simple if we can. So I think we're running out of time.
Yep, we have to wrap up. Thank you all for coming and for the great questions.